All right, we're looking at the analyzing quadratics guided notes. And here, the standard form of a quadratic, anything in the form of y equals ax squared plus bx plus c. And here, I just need you to know that a, b, and c are real numbers. So it's just a number like 4x squared plus 3x plus 2. Right? That would be an example of a quadratic. Now, the graph of a quadratic, this shape of a graph of a quadratic, here it's called a parabola, which I'm sure we're all fairly familiar with. And the first thing we want to discuss is the axis of symmetry. So the axis of symmetry is a line that goes right down the middle, and it would basically be the line in which if you folded the parabola over, it would be symmetric about this dotted line. So the axis of symmetry, it's a vertical line. And remember, vertical lines are in the form of x equals some number. So we just wanted to say that x equals a number. Now the vertex is a point on the parabola that would either be the lowest point, or if you had a parabola that opened down, that's a terrible parabola, but if you had a parabola that opened down like that, the vertex would be the highest point there. So we have the lowest point and the highest point there, which that brings us to the maximum or minimum value. The maximum or minimum value is the y value of the vertex. Now the domain of any quadratic, or every quadratic ever, the domain is always all real numbers. And in interval notation, we just say negative infinity to positive infinity, like that. Now the range is all the y values, right? So all the x values have been handled with a domain. Now the y values depend on whether the parabola opens up or opens down. So if our parabola opens up like this, then it's going to start at this y value of the vertex and go all the way to infinity. Or if it opens down, then it's going to start at negative infinity and go to the y value of the vertex. So the range, again, are your y values. Now the y-intercept on this graph is where it crosses the y-axis. That's this point right here. So the point in which it crosses the y-axis. And again, remember, x equals 0. Right? So it's the point 0, comma, y. So it's going to behave in the form of that. And again, the vertex is a point in the form of xy. Alright, so this is some basic characteristics. Now, we want to be able to find these characteristics. We want to be able to algebraically find these basic characteristics just by looking at the quadratic itself, the original quadratic. So the axis of symmetry is the line. Again, the vertical line that goes through the vertex. So it's going to know, we'll use the x-coordinate of the vertex to say that x equals that. That number will be the vertical line that stands for the axis of symmetry. So here, in order to find that number, it's going to be x equals, and we have a little formula here, the opposite of b over 2a. And here's our b and here's our a. So wherever we get this b and a from, that'll give us the axis of symmetry, the equation for the axis of symmetry. And again, since the axis of symmetry goes through the vertex, then that's going to be the x-coordinate of my vertex. So here, the x-coordinate of my vertex, the opposite of b over 2a. And if I know the x-coordinate, how in the world could we find the y-coordinate? Mr. Thornburg said it's easy. All you got to do is plug it in. So we plug it in, and here I'm going to use function notation. I'm going to plug in the opposite of b over 2a. And it's going to be a little weird at first, but here's my x value, here's my y value. And I'm going to go through an example showing you how to plug in an x value to find a y value and using this notation. Now the maximum or minimum value, well, that's going to be what we just found. It is the y value. So whatever we plugged in there, oh, it's 2a there. So whatever we plugged in and the value we got back for y, well, that's going to be my max or my min. Because the vertex would be my minimum if it opens up, my maximum if it opens down. So it's the y value. Again, the maximum or minimum is the y value of the vertex. Now the domain, as we said before, the domain is all real numbers. So that one's a little easy. And my range, well, it depends. If it opens up, again, if it opens up, my range is going to be from f of the opposite of b over 2a, and it's going to go to infinity. And if it opens down, it's going to start at negative infinity, and it's going to go all the way until I get to that value. Now for my y-intercept, the value of x for my y-intercept, the value of x is always 0. So if I plug that into the original, ax squared plus bx plus c, well, x would be 0. So a times 0 is 0, b times 0 is 0, and I'm left with simply y equals c. So my y-intercept is always the point 0, comma, c. Well, that ain't too bad. That ain't too bad. All right, so let's put these ideas into practice. So here we want to find the axis of symmetry, vertex, maximum or minimum value, domain, range, and y-intercepts for the following function. Here we have f of x equals x squared minus 8x plus 10. Now, I know if it opens up or down by the a value, my value for a. So it opens up if a is bigger than 0, and it opens down if a is less than 0. So that's one of the first things I try and take a look at whenever I get a function like this. And here, my a value is 1. All right, so it's positive, meaning it's going to open up. So now I'm going to find the axis of symmetry, and I'm going to plug in x equals, for my axis of symmetry, x equals, now the opposite of b, which is negative 8, over 2 times a, which is 1. A negative 8 is 8. 2 is 2, and here I get 4. So my axis of symmetry is the line x equals 4. Now I can find my vertex simply by plugging 4 back in. So f of the opposite of b over 2a is really saying f of 4. And in this instance, I just plug a 4 in for all my x values. So I get 4 squared minus 8 times 4 plus 10, which gives me 16 minus 24, wait a second, 8 times 4 is 32, and then plus 10. So 16 minus 32 is negative 16, plus 10 is negative 6. So so clean this up. We say f of 4 is negative 6. So now I could say my vertex is the point 4, comma, negative 6. Now, I want to know if it's a max or a min. Again, this one's opening up, so I'm going to have a minimum value, and my minimum value, I have a minimum of negative 6. It's just the y value that I get from my vertex. And the domain, as we've discussed here, the domain is going to be all real numbers. So negative infinity, whoa, negative infinity to infinity. And my range, since it opens up, I'm going to start at negative 6 and I'm going to go all the way to infinity. My y-intercept, well, again, it's just my c value here. So my y-intercept is the point 0, 10. So now we have a lot of information that we could pull from a quadratic function, really with not a whole lot of work. The opposite of b over 2a gave us 4. Plug 4 back in, we get negative 6. Everything else was just a matter of knowing and understanding what it means, the meaning of it. So this requires a little bit of thinking, but as long as you know and understand the terminology, this is going to be fairly easy.